Okay, so had to figure out how to. Okay, so today we're going to be talking about electron configurations and how to sort of go about writing them with the two elements that I have assigned to me, which are the element with the atomic number 84, otherwise known as polonium, and the element with the atomic number 24, otherwise known as chromium. In order to save time, I had to pre-write the electron configuration right there, and I'll go ahead and break it down in a second. But basically, the way you're going to want to go about writing an electron configuration is looking. I find the best way, easiest, is to look at your table and to travel left from right by breaking down each section of the periodic table according to the subshells of the atom. Right. So when you have these sections in the periodic table, they're each going to be assigned to a different subshell around the atom where electrons are going to sort of occupy those spaces. And you're going to want to write out the manner in which they're going to occupy those spaces according to the element you're trying to find. So, for example, with the element 84, polonium, well, the element with the atomic number 84, otherwise known as polonium. What you're going to want to do is, once you find that element and where it is on, okay, when you find where it is on the periodic table, and you get familiar with its placement, atomic number 84 is here. So you have 4 different sections of the periodic table that are broken down, and it's going to be section S, which is just the sub-level of the shell of the atom. It's going to be S. The middle is D. The right is P, and the bottom is F. And these are all just the different subshells of the atom, and where the electrons are going to just sort of occupy the space. So when you look at element 84, it's located in section P towards the bottom of the periodic table. So you got to go through the entire periodic table until you reach that element and note down your electron configurations while you're going through it, so you can sort of locate and find how many atoms are in the element you're talking about and where they're going to be located. So the way we'll do it is by going through all the subshells, all the sublevels at as they come up. So we start with 1s and we go through 1s2, come back to 2s2, and we are going to reach the next sub-level section of the atom, which is P. So you continue it on, and there's 6 elements per row in each section. So 2p6, because you got to go through the entire thing. Back to 3s2, if you're following along. 3p6. Then we go through the D sublevel, 3d10, because there's 10 elements in that row, and you got to go through the entire thing in order to get to the 84, the atomic number 84. So we go back through the entire D section, back to 4s2, 4p6, 4d10, all of it, 5s2, 5p6, 6s2, 6f. Now we reach the next sub-level of the section. Give me 1 minute. I believe I wrote this down. No. Okay. 5s2, 5p6. Yes. Okay. 5p6. Okay. So now we reach the next sub-level of the periodic table, which is sub-level F. Now, sub-level F is located at the bottom because there's a break in the periodic table from this bottom row of 6 and bottom row of 7. You got to go through the next section first, and the way we do that is by breaking the periodic table and continuing in section F. We got to go through all of section F. There's 15 elements per row in section F, so you count 15. That's why there's 6F15 in the notation. Then we go back up, go through all of 5D10, and we finally reach the P sublevel where atomic number 84 is located, and that's 4 elements into the section, so hence 6p4, and that's going to be our exponent. Now, this is the entire electron configuration for this element. Now, in order to find the quantum number, Let me say now one more time. You're going to grab the last electron, which in this case is 6p4, and you're going to start to write your quantum numbers. So I got to go a little quicker just because of time stuff. So yeah, so in this case, our n, which is going to be our first quantum number, is going to be equal to the value of the coefficient in our last electron, which in this case is 6. And n is basically just, now quantum numbers, the point of quantum numbers is basically just specifying where each electron is in all the subshells. That's all it's doing. So with our n equal to 6, our next quantum number, we're going to go ahead and the rule to this is you grab is according to where the electron is located, whether it's in which section of the periodic table, is going to have a specific value towards it. So in this case, P is 1, S is 0, P is 1, D is 2, F is 3. Since we have a value of P, it's going to be equal to 1. Now, we'll go ahead and number this because when we have our value for the second quantum number, we're going to want to grab the reciprocal of that number. Sorry, that's my dog talking. We're going to want to grab the reciprocal of 1, and and anything in between those two values is going to be a possible value for our second quantum number. So we have -1, 0, and 1, and that's how we'll sort of determine. Now we got to go through as we know, electrons don't like to occupy other spaces and any electron is in. You know, if there's a space they can occupy where you know there's like a subshell that's empty, they're going to want to occupy that first before jumping into another subshell with another electron. So since our exponent is 4, you're going to want to go across the number line once, twice, 3 times until we go back to our first value of -1. By the way, these are all going upwards. And you're going to want to start marking down because you got to, go the opposite direction of rotation. And since we're marking down and since we landed in the last value of -1, our next quantum number is going to be, you guessed it, -1. And so since we landed on a downward rotation, the last the last quantum number is going to be equal to -1/2. And that's how you write electron configuration and a quantum number for an atom. Now that's the first one. For practice, we'll go through it again. So we're going to strike through, and just for time's sake, I'm going to have to speed through the next sort of electron configuration. So the electron configuration for atomic number 24, chromium, is 1s1, 2s2, 2p6, 3s2, 3p6, and then now we move on to the sublevel D. In this case, it's going to be 3d4, and finally 4s2. Now, the last element for chromium lands on the D section of element number 4 of the D section. But the way we write electron configurations, they're weird. So we write the D sublevel before we do anything else. So let me condense this a little bit, and then we'll go ahead and see how we can. Okay. I don't think I'm gonna have time to. Okay, so this is the entire electron configuration. Same process. Our last element is going to be 4s2. Well, actually, in this case, the way this is numbered out, our last electron would be 3d4. So same concept here. 3d4. N is equal to 4, and we're in D. So no. Okay, we're in D. N is equal to 4. We're in D, so that's equal to 2. You're gonna write that out, and the last numbers are gonna be. It's gonna land on 1 in a positive.